assume that this is the sign bit. So that actually we're not going to be able to get to our 255. So this is like, it's like a 0 if it's plus or a 1 if it's negative. So the binary number set here is going to create this to be a plus or minus number. So we're not going to be able to go to 255. But let me see, 125. Well, let me just pick a number so randomly. So 64 plus 32, you are 96. I'll make you 98.
Oh, that water boy.
So this number here, one with well, I don't know what the sign. I assume I forgot which is the sign bit. Who took architecture recently? Is the sign bit set to 1 positive or is that negative? I don't recall. It's been a while. Anybody remember? My Com 249 students.
0 is positive and 1 is
0 is
negative.
positive. Okay. There we go. Thank you. So that's actually a great interview question. Okay, so
I'm parched. That's why.
Okay.
Did I use it this morning? Oh, no. No, I
64,
didn't.
32 plus 2. So I've got 64 plus 32.
Oh, woman, I got to stretch.
4, 8, 98. Okay. So this is positive 98. I'm good. I have my 8 bits. I did not overflow. I'm fine if I want to put something that's 98. I'm even fine if I want to put something in that's 125. Can someone tell me a number that if I try to store in a byte variable would cause me to overflow?
What number? It would be 256. 256.
Really, anything higher than 127 in this case,
Yeah.
because that bit is the sign bit, will cause me to overflow. So if I have 256, I'm going to overflow, right? Because I can only go up to, I guess, 128, 127 if all these are ones. So yeah, you got to be really careful. And so if I knew in this variable that I'm going to be storing how many people got vaccinated in Suffolk County today, is using a byte variable a good idea? I was asked to write a program for CVS, and they said, write a program, and I want you to, on a daily basis, to allow some person to input the number of people who got vaccinated at CVS's in Suffolk County on any given day. And I go ahead and I declare in my Java code byte vaccine. Okay. So I have a variable vaccine, VAC. Was that a good idea for me to do that?
No, because a lot more would be getting vaccinated in one day, right?
God willing, right? Yes, absolutely, God willing. So then I need to say, okay, as a programmer, and this is a software security issue, as a programmer, it's dangerous for me to say byte because it's going to if it's in C++, it's going to probably corrupt other memory if I try to input a larger number. And if it's in Java, it's just going to cause my program to crash. So then I have to look at, well, what is like my worst case scenario? Should it be short? Do I think it's a short? Maybe not. I have to sort of like find out this is when you have to ask your users, or you have to kind of do your research as a programmer and find out what possible values can be there. So maybe in Suffolk County, there's more than 32,767 people a day. So what would be my completely safe bet without going overboard about the data type for storing per day in Suffolk County the number of people vaccinated?
An integer.
Yeah, I think it's safe, right? I don't even know what 2 to the 31 looks like, but I'm going to believe that it's way big enough to probably hold all the people in Suffolk County, as far as when you're talking about digits on that. So I would not do my byte. I would change that to int. And some people like to be stingy with memory, and I understand you don't want to use more than you have to, and maybe using an int is overkill. But you can't choose a smaller value. You can't choose something smaller, because then you're gonna have potential for overflow or crashing so depending on the language and how they allocate memory. Right? So as a programmer, you need to know how many bits or bytes are involved in each of your data types. And when you're choosing your data types, you got to do that accordingly. So hence what that part of the lesson. So any questions on this? Great. And so the last part of the PowerPoint is just sort of those cautionary tales. Make sure you do your code reviews, meaning you go walk through the code with other people in meetings, that inside the code you have done everything you possibly can to have checks and balances to make sure that, you know, there are no overflow situations possible. Test with lots of input, long input, short input, lots of voluminous amounts of input, and look for places in the code where you could be vulnerable, where maybe there is something could be overwritten, and you got to be careful for that. Okay? So in a nutshell, that is the buffer overflow introduction. So before I move on, any questions? Stop sharing that. And I'm going to, for a moment, just bring that down. Okay. Okay, so let me grab some code and here we go. Okay, all right. So we're going to do a little code review together. And I know I'm not sharing right now, but I will momentarily. Okay. All right. So let me go back to sharing. Okay. So now, while I'm taking programming classes, so this is my example with ints. This is C++. How many people have never seen C++?
Me.
Just okay. I should have probably taken the poll that way. Better question. How many people have seen C++?
I mean, I've seen it. I haven't really used it much, but
Okay. We used to have a class, Com 252, which was C++. We kind of replaced it with the scripting languages class. We do our object-oriented. We figured sometimes Com 370 is done in C++. But so, okay. So has anybody like know C++? Don't all to answer once. Oh, stop sharing for a moment.
No, I haven't.
Okay, that's fine. So since I'm getting no reaction, I can't see you, so I'm just do this. If you've seen C++, just do the thumbs up reaction.
Yes, I've seen it, but it's been a while where I've taken
Okay.
C++. It's been a while.
Okay. So Matt, Mike, and John. Okay, so I'm just asking this not because this is a C++ lesson, but because in case I make a boo-boo, I just want someone to have, like, I need a safety net. So and the other thing is, which is great, I'm actually delighted that people haven't seen C++ because one of the jobs, if you know, that you might have someday is to do something in a different language, that you literally have to, in a moment, look at a different language and be able to figure out what it's doing. So how perfect my little snippet of code, I think, is very reviewable to go through it. So so then I'm going to ask those of you who know C++ to actually not do anything, and those of you who don't, that's who I'm looking for you guys to participate. So back at this code, everyone here knows Java, so there are definitely things that look familiar. Okay? So we're going to do a code review. Main is a function, not a method. But so if I ask you in terms of Java terms, does the main function return a value, and how do you know if it does or it doesn't? So I'm referring to now, don't worry about lines 11 and 12. That's kind of just the imports and stuff that you bring along. And include is like an import in Java. But so let's do a little code review. This is the main function. Actually, by definition, a function is void. Is it returning a value? Yes or no?
No.
No.
How do we know that? What word do we know from Java, which kind of hits us over the head with that information?
Is that an integer, the int?
The int might be confusing. It might mean that it's passing back something. So it might be passing back something because it's showing integer. Is there any values coming in? So we don't really know if it's a function, if it's a void or not. As far well, let me change it. We don't really know. It looks like it's actually maybe passing back something. Okay, so let me try to change that. This is a header of a function, also known as a method. It's a little weird because the word void is in a different place. So let's look at this here. Do we think this function is going to pass back a value? And Viola, you were saying it right. You were right. Is it passing back?
It will pass a value back, correct?
Okay, and there's two ways you know that, Mike. You see the word int here, and how else, if you look later on in the code towards the bottom, what's the other sort of bells and whistles that's telling you that it's going to return a value?
Return. And if you had a return and you weren't able to return a value, it's going to give you problems.
Right, so it's going to return an integer value. And then the word void, definitely different than Java, so maybe I retract my statement before. Void is the same in Java, is equivalent to Java's parenthesis parameters with nothing in it. So that means nothing's coming into the main function. And a function by definition in C++ means that it's returning a value, actually. Although there are functions that don't return values, but whatever. Okay, so enough of that part. The header part is most probably the hardest one. Can someone tell me, and I'm going to start calling people, what line 17 is doing?
Is it allocating like 10 spots
Yep.
for an int?
So it's allocating 10 spots. And what data is going to go in each one of those 10 spots?
An integer?
An integer. Great. So we have, wish the number was smaller. It's a buffer. Okay, starting at index 0. Sorry, it's very hard to write 3, to annotate the number 3. Okay, so it is a buffer that, so this is called, and it's called buffer, very clever, they named it buffer. And it's a buffer that has the ability to store 10 values. Okay. And obviously index 0 through 9. So what do we call line 19? What kind of structure, programming structure is line 19 start?
A for loop.
A for loop, right? A for loop. And how many times is that for loop going to execute? I is going to start at 0. And then what's going to happen to I each iteration of the loop?
It'd be 9 times.
9
Equal to
times,
9
right?
times. Yes.
I going through 0, but is it 9?
It's less than or equal to 9.
Because that equal to is there, what does that mean about how many times?
It might be 10 because of the 0.
Yep. So it's going to go I through 0. I equals 10. Oh, sorry, I equals 9. Which if you look, if you're kind of looking at my thing, I is going to be 0, then I will be 1, then I will be 2, then 3, then 4, then 5, then 6, and 7, 8, 9. So I is going to be 0 through 9. So inclusive of that I being 0, that's 10 iterations of the loop. On line 21, what is happening each time we iterate that loop?
Isn't it starting it at like it's starting the integer at 7?
But what is about that 7? What's good? What is that 7? What does that mean? Buffer of I equals 7.
Means you're putting a 7 in each spot.
Yep. So I think you're on the right track. It means you're putting a 7. When I is 0, you put a 7 here. When I is 1, you put a 7 here. And 7, 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 and 7. Okay. And then I just put an output line there to show you that's what's, basically that I is changing each time. That's really what that output does. So if you run it, I don't want to run it just yet, you'll see that I is changing each time. Right? So, and that's how it's funky in C++. Output is like C out with these little less than sign, and then C in is with the greater than sign. So it's a little weird. And endl is just, this is just like saying system.out.print ln. It's comparable to that. So I will go from 0 to 9, and each time as I goes from 0 to 9, the code in line 21, because the loop will iterate 10 times, will store the value 7 in that particular spot, memory position in the buffer. Hence the name buffer, right? We could have called it Bob, but we called it buffer. So what's my output going to be from this code? Am I going to see the 7s? And that you don't need to know C++. You can look at this code and you can sort of speculate what the output's going to be.
Just going to be repeating 7s.
We're thinking the output's going to show the number 7 over and over and over again?
It's going to return 0.
When the function's all over, it's going to return 0, which usually is the code for success. So if we get all the way down here, it's going to say, yep, 0 returns success. But this line of code here, this one right here, line 22.
It's going to be 0 through 9.
Yeah, basically this is my output. It's going to say I equals 0, I equals 1, I equals 2, I equals 3. I'm not anywhere in my code do I actually output the contents of the buffer. Because actually, in this case, this wasn't important in what I'm trying to show you. So I do not anywhere show you the contents of the buffer. So
I mean next to the 9.
Oh, that's in Java too. What does mean, you guys?
Increment.
I'm incrementing by 1. So each time, this is a for loop, it initializes I to 0. Mm-hmm. It checks the Boolean expression or condition. As long as I is less than or equal to 9 each time, it will keep looping, keep repeating the loop. And every time I is going to be incremented by 1. This is equivalent to I equals I plus 1. Right, so let me stop sharing and if I run it, as mentioned, as promised, I is 0, I is 1, I is 2, I is 3, 4, 5, 6, 7, 9, and then after the loop, then there's some constant after the loop. Right. So is there any question? It did not show me the contents of the buffer. Instead, it showed me the value of the variable value I over and over again. So are there any questions as to why the output is the output and the fact that I'm not showing the buffer value? That you don't see 7s. Okie doke. So now, how could I break this? Or what can I do? And I'm kind of blinking in that area. What could I do to try to force buffer overflow to happen? Keeping in mind that I do not have.
I would take the integer buffer and change it to 9 on line 17.
Oh, okay. I could do that. I could make a smaller buffer. Okay. I could do that and that would work. But if I wanted to, so I could do that. All right. So let me do that then. I wasn't thinking that, but I can certainly do that. So then I do that. Basically, I have shrunk or reduced my buffer by 1. And sorry, that was a horrible modification of it, but got it. Okay. So now I only have a buffer with spans 0 through 8, but yet I becomes 9. And there is no 9th, right? There is currently no 9th box. So I'll redraw it. Right? So now I change it, and let me even make it more dramatic. Let me change it to buffer of 5. So I make it even like more dramatic that it's going to be smaller. Okay, and that saves me some drawing too. So now I'm going to annotate and do it. Oh, okay. So now I have 0, 1, 2, whoops, not 2, not there. Two, 3, tell you right now, 4. Okay. So I have now made my buffer smaller. I've changed it to 5. So what do we think is going to happen? So when I is 0, everything is going to be hunky-dory, right? I is 0, things are good. I'll write a 7 here. When I is equal to 1, things are also going to be fine. When I is equal to 2, right? So I'm going to put a 7 in, and a 7 in, and a 7 in. And then when I is equal to 3, put a 7 in. And then I is equal to 4, put a 7 in. And then what's going to happen to I? Because I did not touch the loop. What's going to happen next to the value of I? The loop has stayed exactly the way it was. The only thing different now is the buffer size. The loop stayed exactly the same. What's going to happen? What does I become after I?
It'll keep going 9 times?
Right, but I is going to be 5. But there is no I equals 5 box. And then I is going to become 6. But there is no I equals 6. So what do we think was going to happen when we run the program when I starts going into these values where we don't actually have memory allocated for this buffer?
You should get a buffer overflow or it breaks.
Right, or are we expecting that it's going to sort of crash and stop at that point?
Yeah, I think so. You're going to get an error message.
Okay. Do we think it's going to halt the loop execution?
I want to say yes, because you're going to get into an error. Because if you didn't allocate the memory, something's funky is going to happen. So it just might halt.
Okay. Let's see then. And let me actually just annotate and clear. Okay. So let's go ahead. So we've now made the buffer 5, and yet our loop is staying at 9. So we're expecting to see I equals 0, I equals 1, I equals 2, I equals 3, and then let me write that out before we're kind of expecting that, to say, okay, I equals 0, that's the output. I equals 1, I equals 2, I equals 3, I equals 4, and now when I equals 5, we're expecting to get like an error here. Because there's no memory allocated in that buffer of integers that would allow us to store another variable. We're done, right? Our buffer is full. So let's see what happens. What happened?
It
What we expected to see.
as indicated, right?
What we expected to see. What did we actually see?
It ran. Sorry, go ahead.